You know, whether you're streaming a movie or just sending a quick text, networks are kind of like the invisible architecture of our modern lives. They're so woven into everything we do that we hardly ever stop and think about how they actually work. So today, let's do that. Let's trace the invisible lines that connect our entire world.
Seriously, have you ever stopped to wonder? Really think about it for a second. How did all the information for this explainer travel from some server, maybe hundreds, maybe thousands of miles away, to pop up on the device that's right in front of you? The answer? Well, it's pretty incredible.
That's right. Just by watching this, you are an active part of this massive global system of interconnected devices. It's a truly remarkable feat of engineering that connects all of us, and it does it in an instant.
Okay, so to really get how this whole global system works, we've got to start with the most basic building block. So let's ask the simple question. What exactly is a computer network?
At its absolute core, it really is this simple. It's just any collection of computers, phones, servers, you name it, that are linked together. And that connection is what allows them to talk to each other, to share information, and to share resources like, say, a printer or an internet connection. All right, let's bring this whole concept way down to a personal level, because you are surrounded by networks every single day, and you probably don't even realize it. We're going to start with the smallest ones and work our way up. So first up, you've got the smallest scale, your personal area network, or a PAN. Just think about your wireless headphones connecting to your phone with Bluetooth. Yep, that's a PAN. It's a tiny network just for you. Then we scale up a bit to the local area network, or LAN. This is your home Wi-Fi. It connects all the devices in one place, your laptop, your smart TV, your phone, all through that one central router. Now, here's the thing. These networks aren't just some random mess of connections. They're actually built with specific structures, or shapes, and we call these shapes topologies. And the shape is super important. It decides how fast, how reliable, and how easy the network is to manage.
And you know, you're probably looking at a diagram of your own home network right now. This is a star topology. Every single device, your laptop, your phone, your tablet, connects directly to one central device, which is your Wi-Fi router. It's really simple, and it's super effective.
Okay, next up we've got what's called a bus topology. So here, every device is hooked up to one single main cable, kind of like houses all on the same street. All the data just travels along this shared bus. The big challenge with this one? If that main cable fails, the whole network goes dark.
Then there's the ring topology. And just like the name suggests, all the devices are connected in a circle. Data travels around in one direction, passed from one device to the next to the next. It's a very orderly system, but, adding or removing a device can throw the whole ring out of whack.
And finally, we have the mesh topology. Now, this is a really robust setup where devices are all interconnected with each other. So if one connection fails, no problem. The data just finds another route to get where it's going. That redundancy makes mesh networks incredibly reliable.
Okay, so we've covered the networks right in your immediate area. But how in the world do we connect the device in London with one over in Tokyo? Well, for that, we have to scale up, dramatically, to the Wide Area Network.
And this is where the Wide Area Network, or WAN, comes into play. A WAN connects all those smaller LANs together, across cities, across countries, even across entire continents. The internet itself, it's the ultimate WAN, a massive global network of networks.
So how is this massive global connection physically made? Mostly through gigantic undersea and underground cables. There are a few main types. You've got twisted pair, which is basically your old-school copper telephone wire. Coaxial cable gives you a cleaner signal, think cable TV. But the undisputed king is fiber optic cable. It uses light to shoot data through tiny glass strands at just mind-boggling speeds.
So, we have the physical roads, these cables, but how does your data actually know where to go? Well, just like real-world traffic, the digital world needs rules, it needs addresses, and it needs traffic cops to make sure everything runs smoothly.
These rules are called protocols, and you can just think of them as a shared language. For any two devices to communicate, they have to be speaking the same language. The foundational language of the entire internet is a set of protocols called TCP/IP. It's the universal rulebook that says how data gets broken down, addressed, sent, and then put back together again.
To send anything, you need an address, right? Well, your devices actually have two of them. Think of the MAC address as the permanent, unique serial number of your device. It's who the device is.
The IP address, on the other hand, is its temporary address on the network. It's where the device is right now. You absolutely need both to make sure the data gets to the right machine at the right location.
And now for the traffic cops. A switch works inside your local network, your LAN. It's like a local mail sorter, making sure a file from your laptop gets to the printer down the hall. A router, though, is the big picture device. It's like the main city post office, directing traffic between different networks, sending your data from your home out onto the great big internet.
So let's put this all together. When you type in a website, your request goes from your device, gets directed by a switch inside your home network, over to your router. That router then sends your request out onto the internet, the WAN. The request finds where it needs to go, and then that whole process happens in reverse to bring the website's data all the way back to your screen, all in a fraction of a second.
This entire system, as you can imagine, is constantly evolving, and the next generation of network technology, it's already here, and it's promising connections that are way faster and more responsive than anything we've ever seen before.
One of the biggest leaps forward is with 5G. Now, everyone talks about speed, but the real game changer with 5G is something called latency. That's the delay or the lag in the connection. And 5G doesn't just improve latency, it practically eliminates it.
And this chart just shows you how huge that difference is. We're going from a 10 millisecond delay on 4G all the way down to less than 1 millisecond on 5G. That means the network can respond almost instantaneously, which is absolutely critical for technology that needs real-time feedback.
So, what does this unlock for us? Well, it's way more than just faster downloads. 5G's mix of higher bandwidth and the ability to support tons of devices at once, it's laying the groundwork for some truly futuristic tech. We're talking about fleets of self-driving cars that all communicate with each other in real time, and entire smart cities operating on one seamless, interconnected network.
So from the simple Bluetooth connection in your headphones to a global web that powers our entire society, networks are absolutely fundamental. And as they keep getting faster, more powerful, and a whole lot smarter, they're going to continue to reshape our world in ways we're probably only just beginning to imagine.